The purpose of this video is to dispel sort of a mathematical myth. This is a radical equation. It involves square root symbols. And a lot of people think that squaring is automatically involved and you have to check for extraneous roots. That's not the case here. Notice that this particular strange looking constant is greater than 0. And of course this object is greater than 0, right? So that certainly immediately implies that x has to be greater than 0. So you see, that kind of rules out the possibility of extraneous roots from where I stand. We'll see what you think. Now, one thing important about this simple conclusion is that the absolute value of x is just x, right? That's simple enough. If x is greater than 0, then the absolute value of x is x. That's just the definition of absolute value. Now, so in fact, the absolute value may be superfluous here. Maybe it doesn't really add much, okay? But in any event, we can rewrite our equation. We can change the absolute value of x just to x, which is important, I guess. But, again, a lot of people would be squaring away, isolating, bring this constant over to the other side, then square this side. And then you got to go through and check for what they call extraneous roots. Here, we don't have to do that at all. So again, it's kind of a big deal because that's the way they've been teaching math for the last 50 years. You always have to square when a radical is involved. This is a concrete example of such an equation where that's not true. Okay, so right here, the equivalency just means as you move from one side to the other, that they have the same solution set. I didn't do anything illegal right here. I just rewrote this in this fashion. You see, in other words, what did I do here? I subtracted, well, nothing happened here other than I just used the fact that x is greater than 0 per the equation. The equation itself has a domain of x greater than 0, okay? Now, the very next step involves just the operation of subtracting the square root of x from both sides. And so we get this statement. Now, this would be the spot where a lot of people would square both sides, but it is completely unnecessary. Notice that this is equal to the square root of x times the square root of x minus 1. You see, and it's so easy that it's hard, I guess, in a manner of speaking. I just know that the multitudes would be squaring right here, but there's no need to. You can just factor out the square root of x and you get this, right? But you see, it's still equal to this constant, right? It's still equal to this constant. And so by inspection, the square root of x, I mean, you see how it's kind of neat. Look, this is exactly in the form of the constant term. So what we get right here is the square root of x is equal to 6 root 7. Now at this point, you square and you get x is equal to 6 squared times 7, right? You square both. 6 squared is 6 squared, and then the square root of 7 squared is 7 times 7, and I'm getting 252 right here. Now a lot of you would say, well, don't you have to take the plus and minus here, right here? If you square both sides, you're introducing the possibility of a different answer, But no, I mean, we already know in advance that x is greater than 0, right? X is greater than 0. You might say, well, there would be a minus 252 or something, right? But that's not possible, right? Because you would be taking the square root of a negative number, all right? So this is the answer to the question, 252. Okay. Now, I will concede, I've been yammering quite a bit here. I will concede this problem was kind of designed to prove that you don't have to square radical equations. But again, at this stage of the problem, a lot of people would have just instinctively, including teachers, people who are pretty good at math would just think, well, I need to square here. Of course, you square the right-hand side. And then that would be okay, but it's totally superfluous and unnecessary, okay? So again, the solution to this problem, and the only solution to the problem, is 252. x equals 252. And y'all, again, one more pontificating comment here. It's important to declare that x is greater than 0 at the very beginning of the problem before you start, quote, doing any math. You see how that's so critical, because it eliminates all the squaring stuff. And I know I'm repeating myself here, but observing the solution set, or the domain of the equation, you can think of this as the domain of this entire equation, right? There's no possibility for x to be negative just by inspecting this equation, all right? And not enough people do that. They just get busy isolating variables and squaring, and then trying to get rid of extraneous roots and all that. So again, let me know what you think. And again, I know this problem is slightly contrived to kind of promote the dogma that I'm advancing here. But let me know what you think, and look forward to your comments.